Good morning, everyone. Today you will be looking at covalent bonding, but first, all of you should have analyzed someone else's posts and critiqued them using the class norms and levels of learning. So make sure you go back and look for the definition of an ionic compound, creating a model, explaining what the model means, and predicting the chemical formula. Um, Thank you for doing that. But today we're going to continue on with that same idea, but now with covalent compounds. And you will be writing a kid blog post using the same criteria, but now instead of ionic, you'll be doing covalent bonding. So make sure that you have made a copy of covalent bonding note sheet 3.3. So covalent bonding 3.4. My bad. Make a copy of covalent bonding 3.4. So we're going to start today by just reading what a covalent bond is. Please highlight along with me as we go so that to help you better understand. This portion right here is going to be all about defining covalent. I should have probably stopped and erased this beforehand. So let's go ahead and start. Whether or not a compound is ionic or covalently bonded depends on how much each element needs an electron to get to the magic number of 2 or 8. I would highlight that because we need to get to 8, and covalent bonding has special rules to get to those 8. Elements that are very close to the noble gas tend to give or take electrons rather than share them. These elements often form ionic compounds rather than covalent compounds, meaning metals and nonmetals create ionic compounds. We should find that generalization. Metals and nonmetals create ionic compounds. Covalent compounds form elements when the elements roughly have the same tendency to accept electrons. Elements that are nonmetals, therefore close together on the periodic table, tend to form covalent compounds. So nonmetals form covalent compounds when they're together, with each other having approximately equal tendency to accept electrons. Compounds including carbon, silicon, nitrogen, oxygen often form covalent compounds. So for the rest of this learning target for 3.4, we should be focusing on the upper right-hand side of the periodic table. That's where most of the covalent compounds come from because that's where most of the nonmetals are. So let's find out the definition of a covalent compound. A covalent compound or covalent bond is formed when atoms share electrons. Share electrons. That's the most important part here. They share electrons. That is the definition. A group of elements held together by covalent compounds is called a molecule, blah, 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 blah. Each bond represents a shared electron pair. So our next step is to start creating models. That's the approaching level of understanding. We have 3 types of models. We have the ball and stick model, the space filling model, and our favorite, the Lewis dot diagram model. For today, we will focus on the ball and stick model because that shows you your bond. So right here and right here are bonds. And when you have a bond, you have shared electrons. And once you've had shared electrons and you see this, you're able to create this. So let's focus on the Lewis dot diagram right now to begin with. Our Lewis dot diagrams will look something like this. This is for water. All right. Now we know that these are shared, so we show that they're being shared with a circle around them. Okay. And the way we begin is by starting off with our first compound. So we take our chemical formula H2O. We have our H here and our second H here. And then we find out the number of valence electrons in hydrogen. Hydrogen has 1 valence electron because it's in group 1, so we show it right here. And then we have 1 O. That's right here. And it has 6 valence electrons. But remember back to our showing here that we have a bond, and all unpaired electrons want the bond. So we have 1, 2, 3, 4, 5, 6. So oxygen has enough valence electrons. Now remember that we need to get to the magic number of 2 or 8. Hydrogen wants 2, oxygen wants 8. So let's do an electron count to see if we are correct. Hydrogen, 1, 2. Hydrogen has 2. It's happy. Yay! Oxygen. What does oxygen have? Well, we have 1, 2, 3, 4, 5, 6, 7, 8. Oxygen has 8. Yay! It's happy. Fireworks. All right. And now this hydrogen. How many does hydrogen have over here? 1, 2. It's happy. Thumbs up. Woo, yay. Yay. Thumbs up. All right. So it's happy. This is the key thing. You can count these electrons in this bond twice because they are shared. They are shared electrons. All right. Our next step then is to name electrons or name these chemical formulas. But first, we need to remember that if they have to have 8 valence electrons, we can have double bonds and we can have triple bonds. Double bonds are when 4 electrons are shared. So if you look down here on CO2, we have a bond here and a bond here. We call that a double bond, and we represent that by the sharing of 4 electrons. Now it just so happens that this carbon and this oxygen have a double bond as well, so they share 4. However, triple bond will have 6 electrons shared. Down here, we see an example of a triple bond, and this is nitrogen. So we have 1, 2, 3 bonds, so that's represented by 1, 2, 3. So those are the 3 bonds there, because we have 6 electrons being shared. So let's begin naming, so that's the proficient level, naming our bonds, or naming our chemical formulas. The first thing to naming covalent chemical formulas is you write the first element's name first. So for example, if I had CO2, C is carbon, so I'd write carbon. And then I write the second element with "ide" at the end. So carbon, I have CO2, the O represents oxygen. I take the root and put "ide," so oxide. But we have prefixes to denote, which tells us the number of elements. So the prefixes are used to denote the number of atoms. So carbon dioxide, di. So I come down to my chart and I see that di represents 2. All right, so carbon di, so now I have to go carbon dioxide. Also remember, mono is not used to name the first element. So I want to say mono carbon dioxide, I would just say carbon dioxide. What would CO be? CO, well, C is carbon, so I'd write carbon again. O is oxygen, so I'd write oxide. So I change the root ending to "ide." And then 1, so I see that this carbon, or CO, has 1, so 1 would represent mono, so it would be carbon monoxide. All right? Take a few moments and work through naming them and then finding the chemical formula. First, you're going to name them and find the chemical formula.